Hello folks, in this video I am going to explain about inodes and a file descriptor. These two are important concepts in the file system, but before getting started I want to give you simple analogy to set the stage. We know about the passport system, and passport tells us personal information about a person, that is name, address, date of birth, nationality, and there is unique entry. There is unique entry called a passport number. Uh, for example, if we see here that if we see in dummy passport at person name, surname, nationality, date of birth is present. But apart from this, the passport number is unique for each person, and we know that many people can have same name and surname, but how does the passport system distinguish between them? The simple answer is the passport number, cause passport number is assigned uniquely to a person. Here I have taken example of passport system, but there are so many system like Aadhaar system, PAN system, and driving license system. And in those system there is also a unique identifier present, like for Aadhaar system, Aadhaar card number, PAN card number, driving license number. So now come to our main topic, that is what is inode. We know that computer is made up of files, that is operating system is made up of files, and there are so many files present on a disk, that is stored on a disk. Like if we see executing by ls-r command, these are the files stored on a disk, and there is also possibility that the files have same name across all directories. So how does the kernel distinguish between them? The simple answer is the inode. When we create a new file, the kernel assigns inode to a file, inode to file, and inode is a non-negative integer which is unique to each file. Suppose if we see inode, that is an ls-i, we can see that for a desktop file, that is it is a directory, the inode number is this. For downloads, the inode number is this. For picture, inode number is this. The here is not any common thing, but because the inode number is unique for each file or directory, so inode number is important. And what does it contain? The inode contains the metadata about the file, that is the information about the file, not what. Now let's see what does an inode contain. The main thing is inode number, which is unique ID assigned to a file. After that, the file type, the type of a file, that is the file is regular file, directory, the pipe, the device file. After that, third one is first one is inode number, second one is file type, third one is owner of that file. The owner is divided into two parts, that is UID and group user, the main user of the file owner, and the group of IDs of the file owner, that is group of users of the file owner. The fourth one is a permission to the file, that is access rights. The file is for read only, write only, or execute only. For read, write, execute only. Fifth one is file size, the total size of the file in bytes. The link count 61 is the link count, the number of hard links to the inode. And after and here is the timestamp entries, that is access time, modify time and change time. Access time tells that last time the file was accessed. The modify time tells show that last time the file content was modified, and change time show that the last time the inode metadata was changed. And apart from this, the block pointer is important to access data of that file. Basically, it stores the location of actual file data on disk, that is where is the data stored on a disk. The table of contents, this is a different concept we will discuss in further videos. And the inode I have described here is the disk inode, and it is different from in-core inode. The in-core inode is the inode data structure, that is data structure which is present in the main memory, and this is the disk inode. The in-core inode I will discuss in further videos. So if we see that and we can see for example, we can see this metadata of any of these files. Suppose C workspace directory. So here we can see that the file name is workspace. The size of the file is 10 bytes. The type of the file is directory. The inode number is here, and here we can see that the inode number is mentioned. So you can also see here or here also. The permission to this permissions of this directory, that is it can read, write, execute. The UID of this directory, GID of this directory. Access time, we can see that when I access the file, that is 31st July, modify is also there. Here also time is present, and here is the inode. And when so we can see these metadata about different directories. If we see /etc/, so it is a password file. So it is a regular file. It is basically a regular file. It is not a directory file. So that is for the inode. Now let's move on file descriptor. Now let's move on to file descriptor. To the kernel, every open file is referred to by a file descriptor. File descriptor is a non-negative integer written by open system call. Suppose if process wants to read or data in a file, it must first open it. When it does, it gets a file descriptor, and that file descriptor is then used for all subsequent operations like read, write, lseek, and duplication. For example, if process wants to access, if a process wants to read /etc/password file, then it must invoke open system call, and the open system call will return a file descriptor. And using the file descriptor, the process would call the read system call to read that file. By convention, Unix system assign or we can say that associates some file descriptor to a shell. For example, 0 for standard input, 1 for standard output, and 2 for standard error. And POSIX also POSIX gave symbolic constant to file descriptor, that stdin for standard input, std out file env for standard output, stderr file env for standard error. Let's summarize. A inode contains metadata and uniquely identifies a file on a disk. A file descriptor is a process-specific handler written by Open to interact with the file. In the next video, we will look deeper into how Open system call works and how file descriptor connect to the file system data structure. So, thank you.